Hey there, class. Mr. Prusky here. Hope you're having a good day so far. We're continuing with Chapter 6. This is 6.6, and we're working with rational zeros today. So it's called the rational zero theorem, and basically it's a way that we can find zeros without actually calculating it by factoring. So we can actually kind of come up with possible zeros based on the original equation or original function, and being able to kind of figure out what the possibilities are, and then we can test, really easily using synthetic division, how if they're going to work out or not. Basically, it's kind of cool. So our essential question is, how do I find a zero of a function if one is not already given to me? All right, so this is called our P's and Q's. So the rational zero theorem says if a polynomial f of x has integer coefficients, then every rational zero has the following form. So P in this rational zero theorem is the factor, we'll put factors actually, factors of the constant term. This will all make sense when we go through an actual example. Factors of the constant term with no variables. Constants have no variables. And Q is going to be the factors of the leading coefficient. So basically, if a polynomial is in standard form, which, do you remember what standard form is? Standard form is from largest exponent to smallest exponent, and the leading coefficient is the coefficient or the number in front of the variable with the highest exponent. Basically, that's our leading coefficient. It's the term that sets the degree of the polynomial. Okay. All right. So let's get right into it here. So it says list the possible rational zeros of f of x. So we're gonna go ahead. We have f of x equals x to the third minus 4x plus 12. So we gotta find our p's and q's. So our p's are the factors of the constant term, which is 12 in this case, okay? We need factors of 12. So what are the factors of 12? Well, we got 1, 2 goes into 12, 3 goes into 12. If it's easier, I'll write these out. I'll just write these out real quick. We have 4, 6, and 12. But what you can do, if it helps you to figure out the factors a little bit more methodically, every factor, I'm actually not going to write this here, but basically 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12. So basically every factor has to have another factor that matches with it, all right? So, so these are the factors of 12, but you can just figure out what 12 divides by, and then figure out what it multiplies to get to 12. That's kind of how we find our factors. All right, so that's our P's. Let's find our Q's. Our Q's are the factors of the leading coefficient. Well, what's the leading, what's it called? The leading coefficient is the coefficient in front of the variable with the highest exponent in standard form. And you can see right here in front of the x to the third, there's going to be a 1 there. So our Q's, for this one's going to be really easy. It's just going to be 1. That's the only thing that factors into 1 is 1. So our possible zeros, now that we have our Q's and our P's, so now we're going to write possible zeros. So all we have to do is our P, we're going to do P over Q. It's P over Q. We're going to have to do every kind of combination of this. These are our possible zeros. So our first one is going to be, and also don't forget plus or minus, because there's it's going to be plus or minus possibly for each of these, okay? So we have plus or minus. The first P is 1. The bottom key is always 1, so we don't need to worry about that. Then we have plus or minus 2 over 1. We have plus or minus 3 over 1. Oops, dang it. Then we have plus or minus 4 over 1. So basically, these are all just going to be plus or minus 1, 2, 3, 4. And we have plus or minus 5. We'll just put 5, or not 5, 6, sorry. Plus or minus 6, plus or minus 12. These are all the possible zeros or possible factors of, the possible zeros, not factors. Possible zeros of this polynomial are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, and then 6 and 12. Okay? And that's all the theorem is telling you to do, is that once you calculate the factors of p, which is the constant term, and divide it by the factors of q, which is the leading coefficient. These are the possible zeros. If you were to solve this and factor it, that's what you would get. So our final answer is going to be this right here. These are our p's and q's. These are our possible zeros. Okay, why don't you see if you can try number 2 on your own. See how you do. The factors should be a relatively small number. There shouldn't be a lot of them. So go ahead and give it a try. See how you do. All right, welcome back. Let's go ahead and get into this. We need number 2. We need our p's and q's. So our p's. P's are the factors of the constant term. So the p's are going to be the factors of 7. What multiplies to 7? Well, we have 1 and we have 7. Now we need the q's. We need the factors of our leading coefficient. In this case, x to the 4th is the largest exponent, so this is going to be our q's, factors of 2. What multiplies to 2? Well, we have 1 and 2. So now we need our zeros are going to be x equals, we need plus or minus. We need different combinations of these p's and q's here. So we need plus or minus 7 over 1, plus or minus 7 over 2. Right? Those are all the combinations for 7. Then we have plus or minus 1 over 1. And plus or minus 1 over 2. And really is just as quick as that. That's all we have to do. So these are the possible answers without actually having to factor it. The possible zeros that you'll get for this polynomial. Okay. So we are going to actually, the problem on the back here I do not like all that much. So I think what we're going to do is we're going to skip from example 1. We're going to skip this one and come back to it. And we're going to do an example on the back. Okay, I'm going to kind of show you. So we're going to actually cross off this example on the back here. And we're going to do our own example that's going to be a little bit better, I think. So we're not going to do this. We're going to write this. So we're going to take some time to write this down. So use synthetic division to decide which of the following are zeros of the function. Okay? So we're going to check these numbers right here. We're going to check 1, -1, 0, 2, -2. Okay? And our equation is going to be this. We're going to use f of x equals, we're going to do x to the 3rd minus 3x squared minus 6x plus 8. Okay? So now this one is going one step further, which is to say that, so this is basically we found our p's and q's, and now we're going to test whether they're zeros or not, okay? So we found our possible zeros. Now we need to test if they're actual zeros. And the way we're going to do this is we're going to do synthetic division, okay? So synthetic division, we're actually going to do a new kind of method for synthetic division. We're going to streamline it a little bit, okay? So we are going to do this. We're going to put our, so we need our, we're going to make our kind of table like this. So let me fix that actually. Make a table like this. All right, so we're going to do synthetic division, but we're going to kind of, we're going to kind of skip some steps now because you guys should be comfortable with that at this point. So we need, first thing we need is we need the, for synthetic division, we need the coefficients of the function over here. So what's the coefficients? Well, in front of the x to the 3rd is to the 1st power. Then we have -3. Then we have -6. And then we have 8. Okay? So now what we're going to do is we are going to test each of these numbers over here. We're going to test each of these numbers right here. So I'm going to test 1 first. So we're going to do synthetic division, but we're all going to do it in one line, okay? So this is what we're going to do first. So we're going to kind of imagine that we're doing synthetic division, but we're doing it horizontally now. We're going to bring down the 1 first. So we got, this is 1. And then we have, the next thing we're going to do is we're going to do 1 times 1, which is 1. And then -3 plus 1 is going to be 2. And then we're going to do, actually -2, sorry. -3 plus 1 is -2. And then we're going to do -1 times -2. That's going to go underneath right here. underneath the negative 6, and negative 6 plus negative 2 is negative 8. And then we're going to do negative 8 times 1, and that's going to go underneath the 8, and then we have 8 minus 8, which is going to be 0. So this is actually a possible, this one will work. 1 is a actual 0 of this polynomial. Let me go back. I'm gonna do synthetic division over here again. I'm gonna show you this the old way, and you can kind of see what happened here. Okay, to make sure that we're not confused. So we have we're checking 1. We have 1, negative 3, negative 6, and 8. I'm just gonna show you what we're doing here. We're kind of streamlining this process. So we brought down the 1. That's where the 1 came from. Then we multiply 1 times 1, and we got negative 3 times 1 is negative 2. So you can see over here we have 1 and negative 2. And then we have 1 times negative 2 is going to be negative, oops, that's not what I want. 1 times negative 2 is negative 2. And then we got negative 6 plus negative 2 is negative 8. And then 1 times negative 8 is going to be negative 8. And then 8 minus 8 is 0. Okay, so these are the same thing. They are equal, okay? But we're just kind of doing the bottom row so that we can kind of make this all in one table and not get so confused by doing a million of these charts over here, okay? So we're going to test the rest of these numbers. Let's do negative 1 next, okay? So bring down the 1. So we're going to have a 1 right here. Bring down the 1 first. 1 times negative 1 is negative 1, and then negative 3 plus negative 1 is negative 4. And then we have negative 1 times negative 4 is 4, and negative 6, this one's, I'm going to put a star here. Negative 6 plus 4, so we got negative 1 times negative 4. Negative 6 times, negative 6 plus 4 is going to be negative 2. And then we have negative 1 times negative 2 is 2. And then we have 8 plus 2 is going to be 10. So this one did not work. So basically, if it is a 0, it's going to have a remainder of 0. So this one does not work. We can cross it off, okay? All right. If this is kind of confusing for you, you can stick with the old synthetic division model if you want, but I would highly encourage you to try to kind of streamline it a little bit because it's going to take a lot of space and time to do it the long way, okay? Let's test 0 now. Let's keep going. Why don't you see if you can do the last 3 on your own, and we'll check our answers in a second. Go ahead and give it a try. All right, so we're going to bring down the 1 again, like we do before for 0. 0 times 1 is 0. Then we have negative 3 plus 0 is negative 3. Then we have 0 times negative 3 is 0. Negative 6 plus negative 3, or sorry, negative 6 plus 0 is negative 6. And then we have 0 times negative 6 is 0. 8 plus 0 is 8. So this one does not work either because it is not 0 at the end. We need a 0 for a remainder. Let's keep going. So now we have 2. I bring down the 1 again. 2 times 1 is 2. Negative 3 plus 2 is negative 1. Checking 2 here. Yep, negative 1. Then we have 2 times negative 1. Negative 2, and then we got 2 times negative 1 is negative 2. Negative 6 plus negative 2 is negative 8. And then we have 2 times negative 8 is negative 16. 8 plus negative 16 is negative 8. This one also does not work. We got the last one is negative 2. Let's see if this one works here. Okay, bring down the 1 again. Negative 2 times positive 1 is negative 2. Negative 3 plus negative 2 is negative 5. Negative 2 times negative 5 is 10. Negative 6 plus 10 is 4. Negative 2 times 4 is negative 8. 8 plus negative 8 is 0. So this one also does work. These are the possible zeros here then, okay? Negative 2 and 1 are going to be, they're actually the actual zeros. They're not the possible zeros. Possible zeros are negative 1, 0, and 2, but the actual zeros are 1 and negative 2. Okay? All right, let's go back to the front. Now we're going to put it all together here. Find the real zeros of the function. So we have this f of x equals x to the third plus 4x squared plus x minus 6. Okay. So we need to find our p's and q's. Remember, our p's are the factors of 6. Our q's are the factors of 1. In front of the x cubed. So factors of 6 are 1, 2, 3, and 6. Our q's, our factors of 1 are just 1. So that means all of our p's and q's are just going to be plus or minus 1, plus or minus 2, because you basically dividing by 1 doesn't do anything. Plus or minus 2, plus or minus 3, and plus or minus 6. Those are our possible zeros for this problem here, okay? So yeah, let's get into this. And also, another thing too that we're going to do, once we get a possible 0 here using synthetic division, we can actually, what we can do is we can factor it on our own without having to do the synthetic division for everything, and we can factor it. You'll see what I mean in a second here, but let's get through this here, okay? So we're going to do synthetic division. We're going to check positive 1 first. We're going to check positive 1. I'll make our table again, because 1 may not work. Let's see if 1 works, though. So our coefficients are 1, 4, 1, and negative 6. All right, we're going to test. We have plus or minus 1. We have plus or minus 1. We have plus or minus 1. We have 2 there. Plus or minus 2, that's 4. Plus or minus 3 is 6. Plus or minus 6 is 8 possible zeros we have to check using synthetic division. But maybe we'll get lucky and I have to do all of them. Let's see how we do here, okay? So we bring down the 1 first. Very nice. 1 times 1 is 1. 4 plus 1 is 5. 1 times 5 is 5. 1 plus 5 is 6. 1 times 6 is 6. Negative 6 plus 6 is 0. So this one actually is our first, an actual 0 we found, which is great. So now what we can do is we're going to rewrite this. We're going to rewrite this. Let's see here. So our answer is going to be, so we're going to have our remainder 0. This is our remainder. And we're going to have 6. Remember, we kind of work backwards here. This is the constant. We have 5x is the first degree, and then we have x squared is the second degree. So when we divide it, that's what's left over. So now our new equation is going to be, we have x squared plus 5x plus 6 times, and our other one was going to be x minus 1. Okay? Equals 0. So yeah, remember x minus 1, you could just, if you just want to solve it and just say that it's going to be equal to 1, that's fine. We know x equals 1 for this one. That's totally okay. But I like to write out all the factors just to make sure I don't miss anything. So, but we're good. So now what we need to do, now that we found one of the factors, we can try to factor this other term right here, or this other expression, and we can try to figure out if we can factor without having to test all these other numbers over here. So let's try to do that. So is there a GCF for x squared plus 5x plus 6? No. How many terms? There's 3 terms. Is it a perfect square trinomial? No. 6 is not a perfect square. Is it, so then we got to try smiley face. Let's try smiley face method. We don't want to try to do quadratic formula. Let's see if this is going to work out here. So we need factors of x squared. Well, that's going to be x and x. We need factors of 6 that add to 5. Well, what multiplies to 6 and adds to 5? We're going to do plus 2 and plus 3. And now we can set each part equal to 0. So x plus 2 equals 0, x plus 3 equals 0, and x minus 1 equals 0. So we're going to subtract 2. We're just going to solve it. We know how to do that here. So x equals negative 2, x equals negative 3, and x equals 1. So our answers are going to be negative 2, negative 3, and 1. So you can see that negative 2, negative 3, and 1 were all possible answers up here. But by finding one of the factors, we can try to factor the rest of it without having to do synthetic division and test 2, 4, 6, 8 possible answers by just factoring. We kind of saved ourselves some time here, okay? So the P over Q's will tell you your possible zeros, then you use synthetic division to find one of the factors. And then after that, you want to try to factor what's left over and see if you can find the other zeros without having to do synthetic division for every single possible zero, okay? That's all I have for you today. Thank you for watching. Have a great day. We will talk soon.